Okay, chapter 11, output and cost. Let's set our objectives. After studying this chapter, we should be able to distinguish between the short run and the long run. Explain and illustrate a firm's short run profit and curves. Short run product curve. 3, explain and derive the firm's short run cost curves. So we're going to look at short run product curves, short run cost curves. And finally, explain and derive a firm's long-term average cost drive. All right, a firm makes many decisions to achieve its main objective. And what is that main objective? Profit maximization. Our goal is to maximize profit. Some of these decisions we make are critical to the firm and help determine even the survival of the firm. Some decisions are irreversible, or at least very costly to reverse. Other decisions can be easily reversed, less critical to the survival of the firm, but still influence profit. And all decisions can be placed into 2 time frames. And we're going to talk about the short run and the long run. Short run, time frame in which the quantity of one or more resource used in the production is fixed. For most firms, the capital called the firm's plant is fixed in the short run. Other resources used by the firm, such as labor, raw materials, and energy, can be changed in the short run. And we benefit that short run decisions are easily reversed. We're going to say at least one of the forces is fixed. And for most firms, we're going to say it's the plant. And again, short run decisions are easily reversed. Long run, time frame in which the quantities of all resources, including the plant size, can be reversed. Long run decisions are not easily reversed. So we're going to say long run, a time frame in which the quantities of all resources, including the plant size, can be varied. I don't think I said that right a while ago. And these decisions cannot be easily reversed. A sunk cost. Who can define it?
Our book says a sunk cost is past expenditure on a plant that has no resale value.
A cost incurred by the firm and cannot be changed. It has no resale value. The amount paid for it is sunk. So if we go out and we acquire a plant and we pay for it, that price, that money is a sunk cost. That transaction is a sunk cost. Now let me stress here. Earlier we talked about opportunity costs and how that separated accounting profit from economic profit. Talked about opportunity costs. 2 important economic principles being presented to you today. Chapter 10 was opportunity costs. Chapter 11, sunk cost. And again, when we talk about what I think that you can take from this class forward and outside of the classroom and apply even outside of the fields of economics, it's these 2 principles. Realizing opportunity cost, what it includes, what you're giving up, the highest value of what you're giving up. And finally, sunk costs. Here's what I want to stress. Sunk costs are irrelevant with any present or future decision. Sunk costs are irrelevant to any present. Let's focus on the present. Any present decision. Sunk cost should be irrelevant to future decisions as well. If I go out and if we say a sunk cost is and I'm wrapped up in the cord here. If I go out and acquire a plant to set up production, and after 1 year, I decide that that plant is no longer sufficient for our operations, while I might admit it was a bad decision to acquire it, while as an entrepreneur, I may frown that I've got to put up additional capital again. But it's still a sunk cost. If that plant is still insufficient for achieving this goal, we need to make a change. And the fact that I just acquired a plant a year prior would be irrelevant in my decision at that point. It might cost someone a job, but to the firm's survival, it's irrelevant. Now, to increase output in the short run, a firm must increase the amount of labor employed. 3 concepts describe the relationship between output and the quantity of labor employed. We're going to talk about total product, marginal product, and average product. All right, total product. How we define it?
Is the total output produced in a given period?
The total output produced in a given period. Marginal product.
The change in total product that results from one unit increase in the quantity of labor employed with all other inputs remaining the same.
All right, the change in product that results from a 1 unit increase in the amount of labor employed. Remember, we're seeing this word marginal. We're dealing with 1 additional output, or excuse me, 1 additional input. Remember, I said that was how we would identify, and you would see that term marginal across many disciplines here. Holding everything constant, what does product change as a result of 1 unit increase in the amount of labor? And the average product. Labor is equal to total product divided by the quantity of labor employed. All right, now let's refer to table 11.1. All right, now here in table 1, I want you to focus on the columns headed labor and total product. Specifically, let's look at labor, total product. Total product we'll define as the maximum output that a given quantity of labor can produce. What happens when I employ more labor?
You're able to produce more sweaters.
I'm able to produce more sweaters. Marginal product increases, but eventually decreases. So look, as I add 1 additional unit of labor, notice marginal product is increasing initially. But right here at point C and beyond, we start to see it decrease. and average product decreases as a result. Now, product curves show how the firm's total product, marginal product, and average product change as the firm varies the quantity of labor employed. Here we're going to have a total product curve on 11.1. It's going to show us how total product changes with the quantity of labor employed. So then we're going to put a graph here. Let me move this slide up. Let's take it down here. And we see that as look along the x-axis, and as the number of labor units increases, again, output sweaters per day is starting to increase as well up to a certain point. The total product curve is going to be similar to the PPF. Who can recall what's the PPF?
Production possibilities frontier.
Good job. So here, production possibility frontier. It's going to show what's attainable. It's going to show what's possible. In the short run, what's attainable and what's unattainable. And again, we can look at how output changes as labor changes. The marginal product curve in figure 11.2. Here we're going to show how marginal product of labor relates to total output. So when we have the first unit, how many sweaters are we producing? 4. The second worker hired produces 6 units of output. The third worker hired produces 3 units of output. Now, what is total production after we hire 3 inputs of labor?
13.
13. And then so on. So the height of each bar measures the marginal product of labor. And if we wanted to define that as a bar graph, we could go like this. All right, now almost all production processes are going to be like the one we're showing here. Increase marginal production, marginal returns initially, diminishing marginal returns eventually. So here we start to see initially the marginal product of a worker exceeds the marginal product of previous workers. Now, as we keep in the short run, we're getting increasing marginal returns. Eventually, marginal product of a worker is less than the marginal product of the previous worker. Here's when we're going to define diminishing marginal returns. So we're going to be less, we're not going to be receiving benefits here. Now think of hiring. These are what's going to affect hiring decisions. All right, increasing marginal returns arise from increased specialization in the division of labor. Diminishing marginal returns because each additional worker has less access to capital and less space to work. The law of diminishing returns states that as a firm uses more of a variable input with a given quantity of fixed inputs, the marginal product of the variable input will eventually diminish. Let's look at some more examples. Figure 11.3 shows the average product curve and its relation to a marginal product curve. Now, when marginal product equals average product is at its maximum. And let's look at when we go from 1 to 2 workers. At point C is where we see marginal product intersecting with average product. Now, what's happening to average product after we go beyond point C? As marginal product continues to decrease, what's happening to average product?
It's going to decrease as well, but not at the same rate.
It's decreasing as well. No, not at the same rate. Let's just look at the relationship. Beyond that point, as marginal product continues to decrease, so does average product. This relationship between average product and marginal product, what you're going to find is a general feature of the relationship between the product and marginal value, or excuse me, the average and marginal values of any variables. It's also going to be the variables including your grades. So thinking about the relationship between marginal and average, you're going to find the same relationship in grades. Now, to produce more output in the short run, firms must employ more labor. When we employ more labor, it's going to increase our cost. Total cost, marginal cost, and average cost. We're transitioning here to short run cost. So, set some total cost. Who can define it?
Cost of all resources used.
The cost of all resources used. Total fixed cost. We're going to abbreviate the cost of, go ahead. The cost of firms' fixed inputs, and fixed inputs do not change with output. Total variable, the cost of the firm's variable inputs. Now, variable inputs do change with outputs. So if we were setting up a formula, how could we define total cost?
Equals TFC
Equals total fixed cost plus total variable cost. And how we're separating here is variable costs do change with output. All right, back to the share screen. All right, so total cost. let's look at figure 11.4. Now, as we're seeing, what do you observe about total fixed costs?
It remained constant.
It remains constant. So remember, fixed costs do not change with output. But we notice that as output increases, what happens to total variable cost?
Goes along with that.
It goes along with it. So since we're increasing total variable cost, we also observe an increase in total cost. So the average cost curve gets its shape from the total product curve. So again, as we start to see that as we're increasing variable cost, total cost and average cost is going to start to increase. Now, as total product curve becomes steeper at a low output level, less steep at high output levels. Okay, in contrast, the total variable cost curve becomes less steep at low output. Remember, it's going to rise with output. It's going to change with output. So if it's increasing, if output is slowly rising, our curve's going to be less steep. But if output goes through high levels, we're going to see it get more steep. Now, let's look at another slide here. What's happening here? We see total variable cost curve. What's happening? I'm getting ready to put something else on it here. All right, let's first say one worker costs $25. Two workers cost 50 and so on. So now, here's our total variable cost curve. And we've got cost on the x-axis, output on the y-axis. Now we're going to redraw it. We're just reversing here. Here's where I want to be. So looking at this graph, what do you observe about total fixed cost?
They still maintain act as constant.
Remaining constant. And again, as total variable cost is increasing, total cost is still increasing. How are we going to define marginal cost? The increase in total cost that results from a 1 unit increase in total product. Over the output range, with increasing marginal returns, marginal cost falls as output increases. Over the output range with diminishing marginal returns, marginal cost rises as output increases. Remember I said, we're in a situation of where we're getting increasing marginal returns as cost decreases. That's a good place. But over the output range with increasing marginal returns, marginal cost rises might point to a different outcome. Now, average cost. Still going to find the fixed cost component and the variable cost component. And average total cost is the equivalent of average fixed cost added to average variable cost. So we're highlighting the relationship here between marginal, average, and total cost. Now, here figure 11.5, and this can be observed in text as well. The marginal cost, average fixed cost, average variable cost, and average total cost curves. So first, the average fixed cost curve shows that as average fixed cost falls, as output increases. Now think about that concept, it's fixed. So as we increase output though, the average is going to decrease because we're taking that fixed amount and we're dividing it by a larger number of outputs. The average variable cost curve is U-shaped because in the beginning we're getting diminishing return, benefits from diminishing return, excuse me. We're getting benefits in the short run and up to an initial period. But again, as output continues to increase, that variable component is going to cause the average variable cost to increase. I just told you. The average total cost curve is also U-shaped.
What caused the divergence between the average variable cost and the average fixed cost? I don't understand why they're going in opposite directions.
Average fixed cost. Imagine you took, okay, because of the fixed component, as output increases, you are dividing that fixed component over a larger number of output.
Okay.
So think about it like, you know, if I have a fixed cost of $100 and output is at 10. Okay, now as I start to increase output up to 100, holding this constant, I'm dividing it by a larger number, it's going to cause the average to fall. So here my average would be 10, here my average is 1. Now what if, let's look at it from a variable component. And we'll call this variable. You know that it's always going to increase as output increases because it's directly tied to output. As I employ more labor, we'll define that as a variable cost. If I employ additional labor, I'm driving this cost up. And again, while that's increasing, that's going to cause the total variable cost to increase.
Okay, I understand it better now.
So we'll call that variable and that fixed.
So your average fixed cost is going to decrease as the units of output increase, but those units of output are increasing and taking your average variable cost up with it. Is that correct?
Correct.
Okay.
Looking at this slide right here, if you look at the average fixed cost curve, we'll see that as output increases, it decreases. Again, we're spreading it, we're dividing it among a higher level of output. But variable cost is going to rise. Compare, look right here, average variable cost and average total cost. Both are increasing as output increases. Initially, they're going to fall, but eventually they're going to rise. Where were we? Making sure my notes, I'm trying to get back on cue. All right, let's answer this question. Why is the average total cost curve U-shaped? So what makes it fall initially, but then an increase eventually?
Yeah, no, I think you're right.
So the labor, would the labor cause it to go down and the product cause it to go back up as it increases?
All right, state that one more time for me, please.
My thought was that the labor causes it to go down, but then the labor forces it back up because it's able to produce more quantity.
It decreases at first. But increases as it produces more output. Is that what you're saying?
Yes.
All right, let's look here. Spreading. I think this is the textbook trying to say the same thing that you're saying.
Yes.
Spreading total fixed cost over a larger output. All right, so average fixed cost slopes downward and output increases. We've seen that. Eventually, with diminishing returns, the average variable cost curve slopes upward and average variable cost increases. Again, we're spreading it over a larger output.
Makes sense.
Cost curve. Shape of a firm's cost curves are determined by the technology it uses. Look at a link between total cost and total product, and the links between average and marginal product and cost curves. Now, how do these are going to compare? In figure 11.6. If we plot output against labor, we get a total product curve. And again, we start to see in the beginning, we're steeper. But eventually we start to level out. And what do you think would happen if we continue to take that out? Just out of curiosity. We might eventually see it change course. When output is plotted against cost of curve is the total value curve, but we're flipped over. Now, why are we changing shape here? What do you think can explain? If you look at figure 11.7, we'll look at this relationship. In the upper curve, we see average product curve and marginal product curve. You get it all up here. Labor is increasing up to what? At 1.5 workers, we're increasing up to that point. So rising up to 1.5 workers. Now on the lower level, shows the average variable cost curve. Output increases to 6.5 sweaters per day. Marginal product falls and marginal cost rise. But average product continues to fall. Shifts in cost curves. We're going to say positioning of the firm's cost curve is going to depend on technology and prices of factors of production. Technological changes influence both the product curves and the cost curves. An increase in productivity, we shift product curves upward and cost curves downward. If a technological advance results in the firm using more capital and less labor, fixed cost increase and variable cost. Fixed cost representing the capital, and variable cost representing by the labor. In this case, average total cost would increase at low output levels and decrease at high output levels. All right, prices of factors of production. An increase in the price of a factor of production increases cost and shifts the cost curve. An increase in productivity shifts the product curves upward, cost curves downward. If a technological advance results in the firm using more capital and less labor, fixed cost will increase, variable cost decrease. It's kind of a quick summary. I can tell you there's less in understanding there's less here in the long run. But in the long run, all inputs are variable and all costs are variable. Remember, long run decisions are not easily reversed and all inputs are variable. The production function states the behavior of long-run costs depend upon the firm's production function. And the production function of a firm is the relationship between maximum output attainable and the quantities of both capital and labor. I'm just going to look at a couple slides here. All right, table 11.3. Table 11.3 is going to show the here production function. As the size of a plant increases, output what?
Increase.
All right, given. But for each plant, as the quantity of labor increases, diminishing returns will occur. The marginal product of capital. Let's look at this diminishing marginal returns to labor. All right, here I want to be. The average cost of producing a given output varies and depends on a firm's plant. The larger the plant, greater the output. Average total cost is at a minimum. We're going to look at an example of 4 different plants. Each plant has a short run average total cost curve. And we're going to compare the average total cost for each output at different plants. So let's assign some. Plant 1. I'm going to speed it up, put all 4 up here for you. All right, so here we've got, we just added plant 4, and we have 4 knitting machines. So what shape do we observe? Each short run average cost curve, total cost to be, what shape? We'll say they're U-shaped. For each short run average total cost curve, the larger the plant, the greater the average cost is. What's the average cost curve of 13 sweaters? That's what you observe from plant 1. Where are we at the low point?
Say 10? 10 to 12? 10 to 12?
Yeah, I mean, the book gives us the book defines it at 13, but I'm going to say, yeah, we're right in, we're right in here. For plant 2,
15.
and 3,
22.
you're getting the point. All right, last thing that we're going to look at. The long run average cost curve. Long run average cost curve is a relationship between the lowest attainable average total cost and output when both the plant and labor are varied. The long run average cost curve is a planning curve that tells the firm the plant that minimizes the cost of producing at a given output. And once the firm has chosen its plant, The firm incurs the costs that correspond to the curve of that plant. So the long run average cost curve. Here we're going to trace the lowest attainable average total cost when both labor and capital change. The green arrow. Here, the green arrow is going to highlight the output range over which each plant receives the lowest average total cost. Within each range, to change the quantity produced, the firm changes the quantity of labor it employs. Now, along these curves, economies of scale are going to occur when average cost falls as output increases. So notice initially, if output is increasing and cost is decreasing, we have economies of scale. Diseconomies of scale. We're going to say these arise if average, and I understand this is a tongue twister, but diseconomies of scale occur if average total cost rises as input increases, output increases. So think of it this way, economies of scale, output increasing, cost decreasing. Good state to be in. Diseconomies of scale, output is falling, well, cost is rising as what?
Has the output increased?
Both are increasing. See if we said that right. Yeah, diseconomies of scale, features of a firm's technology that lead to rising long-term average cost as output increases. Now, let's throw some red curves up here. And here we highlight economies and diseconomies of scale. Minimum efficient scale, smallest quantity of output at which the long run average reaches its lowest level. So just think of a U shape, we're at its low point. And we see right here the low point of our U. Now, what is a firm's? Let's see here. If you were asked what is a firm's minimum efficient scale, I'll state it differently. Minimum efficient scale is the lowest scale necessary for it to achieve economies of scale and to operate efficiently and competitively inside the industry. Now, do we think that, question I'll ask, does the law of diminishing returns apply to capital as well as labor?
Well, if you're talking about machinery, you could produce over an efficient level of output, but that would incur more maintenance costs things like that.
Good example. So yes, I would argue that other forms of capital could be applied the principles of diminishing returns like we just looked at with labor. All right, best advice I can give you, because we did go through a lot of graphs, and as I said, a lot of tongue twisters and acronyms. I tried to highlight on each of the figures that are contained in the textbook. So my advice would be to refer back to the textbook and paying attention to those graphs. Referring back to the video, and of course the textbook's going to give you more. I put an emphasis on interpreting the graphs. Textbook's probably going to give you more support behind the inputs of the graph. I focused on interpretation because I believe that's where most of you are having questions, allowing you to read what's available to you. Any questions? All right, that will